Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm sitting down today with John O'Donnell, founder and CEO of Rondo Energy. We'll be talking about decarbonizing industrial heat, which is a topic that seems to be getting a lot of attention in the media lately. I think the reason people are talking about it is that it's responsible for a huge portion of our total carbon budget. The industrial sector contributes around 36% of global CO2, and 74% of industrial energy use is tied to heat. Most of that heat is generated by burning fossil fuels today, and because of the high temperatures required, reaching up to thousands of degrees, we can't just use heat pumps like we can to heat our homes. John and Rondo have developed a zero-emission hardware system that delivers consistent heat at the temperatures industrial users need. They raised their $22 million Series A from Breakthrough Energy Ventures and Energy Impact Partners last year. To introduce John quickly, he has an engineering background and has spent his career bringing new technologies from the laboratory to large scale in several different industries. Prior to Rondo and going back to 2005, he has worked in the field of turning solar energy into industrial heat. He's also been involved in fusion technology development as the lead engineer for the Princeton Plasma Physics Laboratory, and he holds over 20 patents. John, I'm really excited to talk to you about all this. It's an honor to have you on the show. Thanks for joining.
Oh, thank you so much. It's a real pleasure.
So you've been focused on this issue of generating zero-emission industrial heat since back in 2005. How has the conversation around this challenge changed between then and now?
That's a great question. I would say one of the big things that's changed between then and now, you said it earlier, it's getting attention in a different way. It's been clear for a very long time how big industrial heat is. It's a huge portion of world energy use, and as you pointed out, world emissions. For a very long time, people thought this is the hardest to decarbonize sector. It's the sector that is most diverse. Electricity is electricity. You can hook up something, and it doesn't matter what the generator is. The way electricity is consumed is the same. Heat is different in all kinds of different areas. And it's an area that is maybe the most price sensitive. Lots of the commodities that we use, whether it's cement or steel or food, energy is a very significant portion of the total cost of production. And as long as decarbonized solutions are more expensive or a lot more expensive, one of the big things that's happened, of course, since 2005, 2006, the world has gone after a lot of the low-hanging fruit. And one of the magnificent side effects of that has been the 95% plus reduction in the cost of intermittent electricity that has been driven by volume deployments in the electricity sector that have suddenly opened up a pathway to deal with that so-called hard to decarbonize sector by harnessing intermittent electricity, which is now in lots of the places in the world cheaper than burning stuff. It's cheaper than fuel if you can just convert it. So what we're doing at Rondo, go back to 2005 or even 2015, what we're doing made no sense. It was, of course, and physicists will tell you, how could you possibly take a high exergy energy source, electricity, and convert it to this low value heat? There must be more efficient things. And for some things, as you mentioned, for low temperature things, heat pumps will play a role, but it's not about efficiency. It's about economy. It's about money. It's about money efficiency. And so we are at this moment that I think part of why the sector is getting attention is A, the dire state of the climate trajectory, the emissions trajectory gets more and more attention, as it should have been for a long time. But B, there are solutions now, and they are solutions that will not create permanent less wealth for the future. Things like carbon capture, which are by definition a millstone we're hanging over our descendants' necks. You're always going to be spending more than you used to but a source of wealth. You're going to be spending less than you used to for these basic commodities. So it's a really exciting moment. But if you have that means of converting intermittent electricity to continuous heat in some way that doesn't break the bank.
Right. Okay, interesting. So maybe this is one way to think about it. The physics obviously haven't changed. Converting electricity to heat
That's right.
has the same efficiency as it did before. But financially, it makes more sense because the renewable electricity has gotten so much cheaper.
Indeed. It's become the cheapest source of energy humans have ever known throughout history in terms of human effort per unit of energy. Yeah.
Mm-hmm. Okay, so let's talk about the problem a little bit more that you're solving, because it sounds like now you can convert electricity into heat, but you've mentioned this intermittency issue with renewable electricity, and I understand that's kind of where Rondo comes in. Can you explain that a little bit further and why it's important to have your technology?
Sure. You can have as much clean energy as you want if you're willing to accept getting it only 30% of the hours of the year or something like that, maybe 40% in some places. But that means if you decide, I'm going to use clean electricity and I'm going to replace my boiler that burns gas with an electric boiler, 30% of the year, it's going to run on solar power, 70%, some power plant that's less than 50% efficient is going to be burning fuel. Your total emissions, so-called scope 1 and 2, go up, not down. So there's a large conversation about electrify everything. But how do we do it if we're adding new crushing loads to conventional power stations and the grid? So I think it's true. Everybody understands we're in the decade now of energy storage for every purpose. How do we do it for this industrial heat matter? Because if I could get all my energy in 30% of the hours of the year and then use it in 100% of the hours of the year, if I could store it and deliver it continuously, now I can make a 90% plus reduction in the total emissions of whatever production produced in that commodity is. There's still a few days a year where the wind doesn't blow or the sun doesn't shine, and we may continue to use fuel for 10% of our industrial heat for some time, but let's start with that 90% reduction. That's a good first step.
It's pretty good.
So how do we do that? Well, one of the tools that's been around that folks have been looking at for a long time is let's make hydrogen. Let's store the hydrogen. It's a fuel. We can use it. We can burn it. And it works. But the only one problem is that it's about 2 units of electricity per 1 unit of heat. That is because of the electrochemical losses and the compression losses. It works, but it's not terribly efficient. And when we look at Europe and its sprint to get off gas, and we look globally at the sprint to get off fossil fuels, pretty much everywhere we look, the rate at which we can permit and build the wind farms and the solar facilities is the rate limiting step. So a technology that used those renewable megawatt hours more efficiently would replace more fossil fuel and do it faster. So one of the McKinsey guys who worked with us a while ago said this class of stuff that we're doing that people call electric thermal energy storage is a new tool in the toolbox. One of the reasons is instead of using 2 units of electricity per unit of heat, it's a little less than 1.1 units of electricity per unit of heat because there isn't chemistry involved. You just take electricity, and electricity converts to heat at 100% efficiency. Your toaster does that. Your electric stove does it. Your hairdryer does it. Electricity converts to heat at 100% efficiency. Now, find a way to store that heat. Heat storage is really cheap. Coffee thermos. If you have an older laptop and you have a coffee thermos on your desk, the coffee thermos is actually storing more energy than your laptop battery at a tiny fraction of the cost. Storing heat in liquids or solids is a great way of storing energy if you can heat them very hot. The amount of heat they store per pound has to do with how hot did you heat it and how cool did you cool it. That's where the energy is stored. And they're easy to, in principle, to build. And people have been working on heat storage for a long time. When we put Rondo together a few years ago, we had been looking for energy storage during my previous 15 years in solar thermal. built a first molten salt system back in 2008. And we learned a lot about what not to do. And when we started Rondo, we were trying to solve for how do we go fast? What is it that we could go big with quickly? And we found a path. For scale, how much electricity storage is in the world right now? Someone told me that there's about 3 gigawatts of lithium-ion batteries in the world. There is 30 gigawatts of heat storage running right now. The steel industry has been using brick to store heat in these things called blast stoves at steel mills since the 1820s. And there's about 1 million tons of brick in the world that on the order of 20 times a day is heated from about 200 degrees Celsius to 1,500 degrees and then back. And the brick lasts 30 to 50 years in that service. We found a way to use that material. Brick is made from dirt. It's made from clay. You can have as much of it as you want. It's made on every continent. And we had an insight that solved the hard problem, because the job of an energy storage system that hooks up to renewable electricity is to take the energy in really fast and then deliver it continuously. And we had an insight to solve that problem for this material that, because we make fireplaces out of brick, brick is not very heat conductive. And we found a way to solve that problem, which led to where we are. So Rondo builds these units that heat brick just the way your toaster heats bread with radiant energy, and then pull heat out of the brick just the way the steel mills have been doing it for 200 years. Folks have been working on how do we do this quick charging. And one approach, people use liquid salt that we can pump between a hot tank and a cold tank and vice versa. Other approaches, they're trying all kinds of exotic materials, from liquid silicon to graphite to all kinds of materials that need special containment and could turn out to be great. And there are some pretty practical things that actually we know we can build: various versions of rocks in a box or sand in a cylinder that you heat with hot air and then you pull hot air out. We found out those things that use solid materials that are inert materials. Graphite burns, salt can combust and spill, and all kinds. The things that use inert materials are promising. We found a cheaper way to do that in a way that could charge faster. So there is not almost any electric thermal energy storage in the world yet, right? There are a lot of technologies that have been in development. We just turned on our first unit 2 weeks ago, and it's the first one running in the US. It's also the highest temperature one in the world. But we're at the beginning of this point with, because the economics have tipped over. One of the solar company CEOs recently said this is a $1 trillion market. We're certain that he's right. And $1 trillion markets are going to see lots of people trying to enter the market. We think that's spectacular because it's going to take as much deployment as possible, as fast as possible, because we are at this opportunity where electric thermal storage unlocks giant new markets for renewables, in particular renewables that aren't necessarily constrained by the grid, and solves this big problem that previously didn't have solutions economically.
I want to make sure it's hard to have this conversation without talking about hydrogen, because it seems to be the place everyone goes. And so you did the hydrogen comparison a minute ago. I just want to make sure I understand it. You said it takes 2 units of electricity to generate 1 unit of heat with hydrogen. Is that because of the energy cost of producing clean hydrogen through electrolysis? Is that where that energy is going? Or
it's kind of the energy losses at the steps. Good electrolyzers are 70% or more efficient, but then we have to compress it and store it in a tank, and that uses about 10% as much energy as was used to produce it. And then when we burn it in a boiler, that boiler might be 80 or 90% efficient. You multiply those efficiencies together, and in real systems, the International Energy Agency uses a number of 48% efficiency for hydrogen. Now, hydrogen has really important uses. If you want to do seasonal energy storage, you want to move energy from July to January, hydrogen's a wonderful way to do it, because if you store it so it doesn't leak, you can store it for long periods of time. And the other issue is on a per kilowatt hour of storage capacity, it's cheap. And when we look at systems that are 100% renewable, the Europeans have studied this a lot. There are periods of like 14 days when there's very little wind or sunshine. We do need eventually longer duration storage in the mix. Several researchers have done studies that find that whether it's in California or northern Germany, the cheapest 100% renewable heat source is about 70% electric thermal storage and about 30% hydrogen. Again, because hydrogen is infilling those gaps and it's moving cheap energy from July to January when there isn't as much solar, for example. It's not either or. Ultimately, they're side by side. But again, if right now, until you're about 70% renewable, you want to sprint as fast as you can with the electric thermal storage technologies because they save twice as much fuel per limited renewable megawatt hour.
Makes sense. I was expecting you to say on the hydrogen side that distribution and logistics are challenging too. Like we just don't have a distribution network for hydrogen yet. And as I understand it, you're taking advantage of the existing electrical grid, right? You don't need any new for Rondo's solution. You don't need any new distribution infrastructure to support this.
I think, this is an interesting point. In what we're doing, it's the electrons that will move to the point of use, and the heat will be stored and converted at the point of use. And for hydrogen, you could do the same thing. You could run the electrolyzer and storage system at the point of use. There is the opportunity to move molecules. Almost every analysis finds that it's cheaper to move electrons than molecules. On the other hand, there are completely different regulatory frameworks. One of the things that we find again and again is that down the electrify everything pathway, what we're doing, and for that matter, what the electrolyzers are doing, is creating an entirely new class of electrical loads that were never considered when grids were built and when electricity regulations were created. I mean, the whole notion of if you have a megawatt load, there needs to be a power station that can carry that all the time and have it be reliable. We're saying, no. This is a source of electricity load that can follow generation instead of generation having to follow the load. And in a lot of cases, there are obstacles today, at least in the electricity system regulation. But you mentioned the grid. One of the really interesting things, both about the electrolyzers and ourselves, is a single factory that's using 5 megawatts of electricity, maybe using 50 or 150 megawatts of heat. And delivering that heat continuously may take 450 megawatts of generation that's running 30% of the time to give you 150 continuous. So suddenly, there's the opportunity to build a utility scale wind or solar facility that doesn't need a grid connection to that industrial park or that factory, because it doesn't need to be carried all the time, because it is generation following. And again, today in lots of places, we don't have the ability to do that. You can do it in Texas. The other place that it's just happening right now, starting next month, is in Denmark, where the Danes have realized, oh, look, we're blessed with massive wind resource. Let's make it possible to repower our industry without having to go through all the difficulties of upgrading the grid, because they've observed this is possible. Lots of governments are looking at that now.
Okay, so that means a factory might have a dedicated wind farm.
That's right.
To support their operations. And today in the US, that's not.
In some places it's possible, in some places it's not. That's right.
Interesting. Okay.
The US is 51 different electricity markets.
Yeah. I want to understand the business model just a bit. So what is the business model? Are you selling capital equipment, and who are your customers? Or do you sell a service? What does that look like?
Yeah, that's actually a deep and very interesting question, because of course, every industry, whether you make baby food or steel, you buy your existing fuel as a service. And the solar industry and the wind industry have figured out how to sell wind and solar electricity as a service on power purchase agreements of every kind. And we're just at the beginning that heat as a service contracts are going to play a huge role in coupling investors who want to build infrastructure and get long-term returns and factory owners who want to save their capital for their own factory production facilities. They don't want to be in the energy business. They want to be in the potato chip business or the tomato paste business. So we do see heat as a service as a critical part of the business. And now, are we originating those heat as a service contracts? In some places, yes. In other places, there are already developers originating heat as a service. And in both cases, Rondo's fundamental business is delivering guaranteed turnkey heat batteries everywhere in the world.
So it's the batteries is what you're selling. And who's purchasing those? Who are your direct customers?
Well, and again, in some cases, it's the direct end user of the heat.
Right.
And in other cases, it's a developer who is creating a facility that sells energy. So some customers want to buy energy. Others want to buy equipment and procure their own energy. And I think as we see these markets develop, the answers to your question will be about as diverse as they are today, just in wind and solar. Some people decide they want to own what's on their roof, or they want to contract for a dedicated generation facility, or they want to do a virtual power purchase agreement. We'll see all those kinds of things in this market as it develops.
And do you think you'll be replacing natural gas boilers in existing facilities, or is this going to be mostly about new developments and putting your batteries into new facilities?
Yeah, that's a great question. And our first laser focus is making this. We build two models that are direct drop-in replacements for conventional gas-fired boilers. They make the same kind of steam. They hook up to the same infrastructure so that it is seamless. And the retrofit is the first place to start, where we can offer lower cost energy without changing the factory. And there certainly are cases where it will be new build. We have customers who are planning a new factory that will be green from the get-go. But a lot of the opportunity is retrofits. Now, on the other side, however, for steel mills and cement plants, integrating high temperature heat that's coming in the form of superheated air or superheated CO2, the process equipment that makes cement or steel that today is powered by internal combustion, that process equipment needs to change. So as we're engaged in those conversations, we have a common technology platform. We have this superheated thermal core, and we deliver it either with a built-in boiler, or we work with others to connect to other industrial infrastructure. And over time, I think the answer to your question, I don't know the answer to your question on that second case. We see the steel industry today building fundamentally new steel mills that are going to use hydrogen rather than retrofitting blast furnaces. I think it's an open question in the cement industry. We have a project right now with designing with partners a zero emission cement production process. It's still an open question whether that will be retrofittable or will be built in new facilities.
Okay, cool. And how do the unit economics compare? Like for a unit of heat, is that the right way to look at it?
Yeah, that's the right way to look at it for sure, because there are a certain number of units per heat per gallon of biofuel or units of heat per pound of tomato paste. And what do those units cost determines, is my commodity the lowest cost or the highest cost in the market? Energy cost really matters a lot to competitiveness of the industry. So that's the first thing that everyone looks at. Okay, is it green is great, but is it more or less expensive than what I'm doing today? And the biggest portion of what that cost is what did the electrons cost? What did my wind or solar power cost that I'm running through the battery? One of the things that we found again and again, I think I mentioned it earlier, What we're doing is so simple. I mean, we really are using the same hot wire material that's in your toaster. Your toaster can turn on and off in an instant. By building a system that can charge very rapidly, we find in many places we can capture electricity that was otherwise going to be negative price or zero price or curtailed in places where we're connected to the grid. Or we can build renewable generation that exports part of its power and uses other power, and that we can find much lower electricity costs than you'd think. There are projects that we're working on in Europe that in pre-war economics, continuous electricity was over 60 euros a megawatt hour. But intermittent electricity, the cheapest 4 hours every day, is under 10 euros a megawatt hour against a cost for burning fuel of around 35. And there are lots of places in the US where those kinds of things are true as well. Sorry, this is a long answer, but the most important thing is, what does the electricity cost? Because we've made the storage so cheap that on a financed basis, the storage is only 20% of the cost of the whole facility.
I see. Fast charging storage is such a key part of making it economically attractive, because that means you can use the cheapest electricity throughout the day to charge it and then use the stored thermal energy whenever you need it, right? I was hoping you could help me visualize what we're talking about. And actually this is great because we all have toasters or something like this in our home with these heating elements, and you keep mentioning that. Are we literally talking about resistive heating elements just like what we would see in a toaster oven or something?
Yes, a lot of them. Yes.
A lot of them.
Exactly that material. The key insight was that if you want to heat brick, you need to do it across a large surface area, and you need to do it uniformly. It's not very heat conductive. If you want to push a lot of heat in, you need to do it, and it's somewhat brittle, so you have to heat it uniformly. We had an observation that the laws of physics, objects radiate heat proportional to the fourth power of their temperature. If you have two things that can see each other, they'll come into the same temperature by trading radiation. We found a way to use that and build this giant pile of brick with thousands of tons of brick that internally is a checkerboard of open boxes and brick. And every brick is surrounded by open boxes. Every box is surrounded by brick. And heaters pass through that array, and they light up the insides of those boxes. And warmer areas of brick participate in heating the cooler areas. So we get the thing we're looking for, rapid, uniform heating of big surface area. But from the outside, a Rondo Heat Battery just looks like a big shed. It's a featureless building, and a heat battery that it's the densest, to our knowledge, stores the most per square meter of land. 10 by 30 meter heat battery delivers 480 megawatt hours a day of energy, storing around 320 in order to do that. This is a different kind of battery than you think of as electrical batteries that I want to move energy from noon to 7 p.m. in a solar area. Here, no. I turn this thing on, I turn the boiler on, and I turn it off a year later for inspection. So part of the period, we're charging and discharging at the same time, and part of the time we're just discharging, right? That is, the boiler runs dead level. But again, from the outside, it just looks like a featureless box. But inside, the thermal core has this structure where radiation pushes heat in from the same electrical heating materials as your toaster. And then air is circulated upwards through that brick structure to pull heat out. You push air in at about 150 degrees C, and you get air out at well over 1,000. And then you pass that over a boiler that's internal to the box and recirculate it, or you deliver that superheated air to some industrial process. It really is almost embarrassingly simple. One of the greatest compliments we get sometimes is, oh, this is boring. And that's the point. If it's not boring, if you have some stuff to prove about, will these materials last 10 years or 30 years, it's going to take a while before you're going to get to the goal, which is huge volumes of low-cost infrastructure capital, driving deployment, making it possible for everyone to buy cheap heat. The requirements for that, we must have technologies that we know are long-term reliable. And we're right at the early points of proving that. We've proven all the materials are reliable. And now, over the next year, we're proving that our customer systems are reliable so that very soon we can unlock the magic of the market that's building conventional renewables today to really be at scale building renewable heat.
Where did that insight come from that drove the design of your thermal core and the structure of the bricks? Is that something that were you looking for this solution specifically?
I would say, it was an overnight success after 15 years of bashing our head against the wall. I'm honored to work with folks I've been working with for 15 years in previous companies. And we learned a lot about what not to do previously. And as I said, when we put Rondo together, the goal was, how do we go fast? Because the first barrier of is there a low-cost energy source? Okay, that's now in place. So it is now just the storage that's going to be the rate limiting step. How expensive that storage is, what does it cost, and how fast can we make it? There are a lot of storage technologies, as you know, that rely on exotic minerals or things that are the supply chain. As far as the eye can see, the supply chain is going to constrain how fast that storage can go to scale. So one of the lenses we were looking through was, okay, what is it that could go to large scale now? And what almost started as, well, this couldn't possibly work. This will never work. The stuff that the steel industry was doing, there had been academic research for a long time on how could we use these materials that run up against this problem of, well, how do you heat it uniformly? How do you keep it from overheating and cracking and stuff? And I think it was about design revision 75 where, the lights went on and that's what we should do. So perspiration leads to inspiration.
Cool.
My co-founder, Pete Von Behrens, is the smartest engineer I've ever worked with in my life. And maybe that's the other answer. That's the short answer to your question.
Yeah, that works too. One thing that stood out to me on your website, it says heat at the outlet is delivered at exactly the desired temperature via automated AI patented controls. And that stood out to me just because one of the things we do at Synapse is use AI and ML to control complicated systems like this. So I was curious, is that a place where you've had to innovate? Because this is what you're doing is new in the sense that you're leveling out this intermittent source of heat. And what does that AI system look like? What does it do?
Yeah, and that's an area that we're at the tip of the spear in the development. I mentioned that the value of these systems is highest when they capture, for example, the lowest cost energy. And there's going to be a lot of work, some of which has started in using forecasts, generating forecasts, looking at weather forecasts, generating forecasts of availability, looking at forecasts of other energy use. If I had a perfect crystal ball and I knew over the next 4 days, what does the minute by minute energy price look like? I could do an awful lot of optimization of the value here. Now, a ton of that kind of work is underway across everything in energy storage today. And we play a role in that. There is another set of areas having to do with asset management and surveillance, where you're going to have fleets of thousands, hundreds of these. Are they all performing internally the way we expect? Do we see any divergence in a small number of outside things that we're measuring that we're going to fold back and say, something's happening inside that unit? Again, that's an area where phenomenal work has gone into management of other kinds of assets. And as we go forward, those things are going to be important in these units. Today, our first customer unit that's now in operation is a little testing example for that, because just beginning to use price predictive charging in that unit is one of the exercises that's underway right now.
Cool. I'd love to talk more about that. What has been the biggest challenge for you getting to this point technically from a hardware standpoint?
Well, the biggest challenge really has been building the team. There's a lot to do in bringing full systems to scale and building manufacturing capacity, finding the right partners, really exploring in detail. Yeah, there's 1 million tons of this material in the world. How is it produced? Who produces it? How do you make it at high quality repeatedly? And those are areas that we spent a lot of time, particularly over the last 18 months, in completing the first commercial unit, taught us a lot about all the matters that were needed for the full-scale units. And I think one of our biggest accomplishments is we've built a relationship with one of the world's highest quality producers of this brick material that serves other industries. And we're in volume production with them today. So one of the things that we need is manufacturing superpowers. And we're headed down that road because I think the company goal is 1% of world CO2 in a decade. And it sounds crazy, 15% in 15 years. So that says about half of industrial heat in 15 years. For sure, there are no materials, supply chain, other matter limits to doing that. And if we're right, there are economic tailwinds at every step of the way. So the big challenges have to do with building the organization, building the execution capacity, building our supply chain partners. And again, we're at a very interesting inflection point right now. We're super excited with how the first commercial unit is running. And I'm even more excited about the manufacturing partnership that's now producing good product and ramping in volume capacity.
Yeah, those relationships are really key. So let's talk about that future state. So 1% of, say it again, 1% of global
CO2.
CO2
yeah.
in a decade.
That's right.
And is a decade from when?
So from last year. Yeah, that's right.
Okay, by 2032. And then 15%.
5 years
15%?
That's right.
5 years after that. Okay.
So roughly, 5 gigatons. Yeah, that's right.
Okay. What does that mean from a scale standpoint for you? How many batteries are out there? And did you say you're not worried about material supply chain?
That's right. There are just our current supplier. Our current supplier with very modest capacity expansion could get us at least halfway to that 1% with a single production facility. The production of these materials, kilns are cheap. They take a couple of years to build, but they're very, a gigafactory is under a $10 million thing. It is a really extraordinarily low cost thing. And we have to look at is what is the supply chain? Where is the dirt coming from? Where's the clay coming from that the brick is made? And how can we, over time, shorten the distance that we're moving clay from place A to a finished product in place B? It does happen to be very energy efficient making these things. A Rondo unit, I'm still not sure I completely trust the calculation, but the calculation is that in terms of repaying its embedded carbon, it's about 27 days from when you first turn it on to where it's repaid its embedded carbon.
Wow.
Maybe we're off by a few weeks. We're still working on that.
Yeah, even if it's, yeah.
Because really, if you think about the original processing of the material, it's like a couple of days of the energy that you put into it when you're using it. A lot of the materials are very low in carbon intensity to make.
Yeah, that's incredible. So I have a few last questions for you. The first is, how optimistic or pessimistic are you about the future of our planet and why?
Well, I'm terrified. I'm terrified that the world that we're leaving to our children, our grandchildren, is utterly unrecognizable from the one that we grew up in. And if we just go out a few generations, we are not moving nearly fast enough to deal with the greatest challenge of our time, the greatest challenge perhaps that humans have ever faced. We've never had the ability to change the planet the way that we have today. And we also have the ability to go back and change the other direction, right? It's not like we are waiting for someone to invent something that will solve this problem. We have the tools. And the best thing of all is we now have the tools that will deliver a future that is not permanently higher cost. It's a false narrative that wasn't false too long ago, that a decarbonized future leaves us all poorer, leaves energy as a higher cost. We're now at this point that that's not true. A decarbonized future, the faster we go, the lower the long-term production cost is of the commodities that affect the lowest income people in our world, right? The faster we go, the worse the most serious impacts are. I have always been a technology optimist. I have always believed that, look, what brought us out of caves was engineering and technology. And we are at this enormously exciting moment, but we have to put it to work as fast. And we're not doing that yet.
Yeah.
But again, that's something that's in our power to change. We can do that.
Right. Who's one other company or person doing something to address climate change that's inspiring you?
Boy, there are a ton of people doing stuff to address climate change that's inspiring. I'm not even sure where to start. One of the things, and it may be because of like what I'm looking at right in front of me, but we are working with some of the world's biggest chemical producers, miners, producers of everything from food to driving data centers, all of whom are seeking ways to change what they buy and who are driving technology forward. So I mentioned we have a dream team of our founding investors, but what I'm seeing is across the market, companies with very aggressive emission reductions goals by 2030, a really meaningful time frame, who are actually doing it. Like, I find that deeply inspiring. And financiers who are recognizing, there are financial institutions that we're working with who are driving giant investments in energy efficiency projects and new kinds of renewable infrastructure. And those two things together harness the power of our industrial civilization, harness the power of capitalism at its best. And it's that stuff rather than, I know a lot of what your focus on is awesome, is fundamentally new technologies that do new things. But the context is that I always look at is, where are we going to see giant capital flow? And that market has to exist, and it does.
Mm-hmm. That demand is there.
Yeah.
Yeah, no, that's a really good kind of bigger picture view of it. What advice do you have for someone who isn't working in climate today, but wants to do something to help?
Yeah, start working in climate. It is the greatest challenge of our time. And that cuts across really every sector. Wherever you are, bloom where you're planted, and ask yourself that question. In my organization, what can this organization be doing? Whether it's changing what it's buying, and there are a ton of people to learn from. I look at things from a technology standpoint, and where is it that we can bring technologies to market? And that is everything from AI and digital controls to mechanical engineering innovation to electrical engineering innovation. There are all kinds of areas, but everything across regulatory, everything in politics. That's not terribly useful advice, though. That just says, work the problem. I don't have a big enough perspective. There are lots of people who do.
No, I love that. Bloom where you're planted. I like that. And it doesn't necessarily mean a big jump to a new company or a new industry. Every industry has to change. And
yeah, Bill Weil at Climate Voices has been very articulate about that like every business can look at what can we do, and because it does mean awareness across everywhere, that we're changing every part of what we're doing, and sometimes those changes are not big changes.
I like that. I'm going to look up Bill Weil. John, this has been really fun. I'm really excited about what you're doing. I love the perspective you bring. I've learned a ton. Thanks so much for all your time.
Dylan, thank you. Yeah, I'm delighted with what you're doing, and it's an honor and a pleasure to speak with you. Thanks.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.